Okay, for example 7, it says a rectangular prism, or rectangular page, excuse me, is designed to contain 48 square inches of print. So I've drawn a picture of a page here. The margins on each side are 1.5 inches, so I have 1.5 inches on each side for margin. Top and bottom margins 1 each, so 1 inch top, 1 inch bottom. And it says what should the dimensions be for the page, so what should the dimensions of the page be so the minimum amount of paper is used. So we're looking for the dimensions of this little gray area right here. Okay, that's why it gives us X and Y. So to start out with, the dimensions of the printed area is going to be 48 square inches, so we're going to go X, Y equals 48 inches squared. Okay, and that's the printed area. If I solve that, so X, Y equals 48. If I solve that for Y, I get Y equals 48 divided by X. But I also have to go to the dimensions of the entire page, not just the printed area. And so to find the area of the whole page, length times width, well, the length for the whole page is going to be X plus 3, because I have 1.5 inches on each side, times Y plus 2 because I have 1 inch on the bottom. Okay. Now what I'm going to do is, remember, this is the printed area, of the printed area. I solved for Y, so now I have a value for Y. I can plug in over here and get X plus 3 times 48 divided by X plus 2. I'm going to plug that into my calculator underneath Y equals. As you can see, I have X plus 3 and 48 divided by X plus 2. I'm going to graph it, and you get that picture. It doesn't really show me much. So I'm going to start with just changing the settings here. I do know that I have to have the minimum value. It wants to know, use the minimum amount of paper, so we're looking for a minimum value. Well, we also know that it has to be positive, so any X over here doesn't work, so I need to see more of this graph. So I'm going to zoom out a little bit, zoom out, and actually what I'm going to do instead of zooms, I'm going to change the window. And since I need X to be positive, I'm going to change that minimum to -1. The maximum I'm going to change, let's say, to 100 just to see what would happen. Y minimum -1, and change the Y also to 100. Graph. Now I've got this picture right here, which is the top half of my graph. So if I were to draw a picture of this graph, it essentially looks something like this. With some type of slant asymptote going on. But anyway, it gave me that. So now I need to know the minimum value, so I'm looking for that point right there on the graph where the blue marker's pointing to. So to find that minimum value, second, trace 3 for minimum. Alright, so left bound, remember flashy thingy, I've got to find it on there. This could be a little tricky now, I can't really see the graph very much. It looks like I'm not going to be able to work this for well. Sometimes that happens. So what I'm going to do is, I need to bring the graph down. So I go back into window. Instead of Y being 100, I'm going to call it 200. And now the graph came down more into my picture. Second, trace 3 again. And there's flashy thingy way out there. So I'm going to bring it back. There it comes. Okay, so there it's left of the minimum spot, hit enter. Now I'm going to get it right of the minimum spot, so somewhere in there, hit enter again. And at the bottom of my screen it shows X being 8.485281, so X is going to be about 8.5. Okay, well the whole page being 8.5, I'm going to add 3. So the page is 11.5 inches on 11.5 inches in one direction. To find the Y is going to be 48 divided by X, so 48 divided by 8.5, which is about 5.6. And then for the Y is, so the Y value, or the width of the page, is +2, so 11.5 inches wide by 7.6 inches long. And there are the dimensions of the page that we need to minimize paper being used.